Now let's have a look at types of testing. Now it's not strictly part of the process of testing. If you're going to have any reasonable planning and any reasonable process, you'll have to understand the different types of testing. So in this topic, I'll have a look at unit testing, integration testing, system testing, regression testing, and I'll have a look at the economics of testing. I won't delve too much into white box and black box testing and acceptance testing and other such topics. There are a lot of topics and there are entire subjects and books written about it. I'm not going to cover that in a 5-minute talk, but I will give you a brief look at the different types of testing. Let's start with unit testing. A unit test is to test a unit of software. Now this is not a routine or a class or a method or something. It is a unit of software, whatever that unit happens to be. And there could be some very big units. But it is just to test that unit in isolation. It's usually performed by a developer. Now mostly what people refer to as unit testing is the developer develops something, the developer tests to check whether it's working correctly, they run that test, and that's a unit test. That's the normal view of what a unit test is. Now what you should test in a unit test, well, you should check that it does what it's supposed to do. That's the first thing. Frequently too, a unit test will check all possible branches, so you're checking not only that it goes through the happy case, but it goes through all the exception cases as well. Does it behave itself? And you might want to test all the valid parameters, just to make sure it can handle all the data. Now, the economics of unit testing. Automated tests must be designed, developed, and debugged and maintained. I mean, writing unit tests costs about the same as writing the code. Let's not kid ourselves. It doesn't come for free. It's definitely not for free. In general, automating the unit test is only worthwhile if the software is going to continue to have an existence. Having said that, unit testing has done more for the quality of software than anything else I can think of. Integration is probably the next step. You've done the unit test, usually it's the developer who's done the unit tests. Integration testing, it's a toss-up. Sometimes developers do it, sometimes the tests do it. But the integration testing is testing that the interfaces between different components function and that the different components do what they're supposed to do. The exchanges work well. Now, a typical integration might be you've got a module and it interfaces to a database. Okay, does that interface work? We're not talking about typical user scenarios. We're talking about exercising that interface. Does it cope with the volume of traffic? Does it take all the legal parameters? Does it reject illegal parameters? Does that user interface, or does that interface, sorry, not a user interface, does that interface function the way it's supposed to do? This is something you can do in integration testing, where you can have test harnesses and more controlled conditions. The economics of integration testing. The cost of integration testing and then system testing can be quite high. Now, it depends what you're integrating. If you're integrating all the systems in a modern warfare submarine or something like that, you're probably not going to do that too often because, you know, just doing the integration itself is quite an expensive exercise, and the testing as a consequence is not trivial. So the integration testing depends what it is you're integrating. If the cost of integration is reasonably small, then you probably would do it more often. Now this was exercised by, introduced, I think when Microsoft introduced the code and sync method. So people would code during the day, whatever they finished during the day, and you know, somebody might code for a week and then check in their code. But each day, the build would take all of the software that had been checked in, build it into the product, run every test that they already knew about it, and see if the whole thing worked. So there was the daily build and test. Now, beyond that, I think each week Microsoft would take the the build that they finish with at the end of the week, and they would take a copy of that and go off and run some more extensive tests than the automated tests that were done. But the integration testing is can be expensive when the integration itself is quite expensive. So it kind of depends. System testing, as opposed to integration testing, is system testing because you have the entire system and you're exercising the entire system. So there you kind of lose control goes through the interfaces. So maybe you're not able to set up the conditions to test an exception for the particular interface. But you do what you can. And there are people who point out that there are some things you can't quite test. I mean, a radar system designed to detect an incoming missile, it's very difficult to set that test up, and you probably wouldn't want to do it too often. However, we've got to run system tests. We're talking about more realistic commercial systems. You set up a system test and run it. The system test is to check the system has the required functionality and qualities. It usually is very time-consuming. It's normally performed by specialist testers as opposed to the developers. Now, you could take a developer and turn them into a tester for a week or something, but that's a different matter. What to test? Well, you test all the requirements and test each of the required attributes. That is things like performance, security, reliability, robustness as much as you can, recoverability, usability as best you can. There may be other things. It depends entirely on the circumstances and what the nature of the problem is. Regression testing is something that you might do if you, particularly in agile software development, you get a new release and the question is, well, what has been changed? The point about regression testing is not that you're testing new functionality. That's a different matter. That's integration testing or something of that nature. Regression testing is checking that what has been done has not compromised something that was previously working. That the system has not regressed. You had it at a certain stage, it worked at that stage, or something worked at that stage. Has what you've changed made things worse? Has it regressed? What to test? Well, usually this is in response to fixing some defect as opposed to introducing new functionality. But you check, is the defect fixed? And has the defect altered something else? Has it degraded something else? So for that, you need some idea of the impact trace for that particular defect. I did say I wasn't going to do acceptance tests, but I do have something to say about it. Acceptance test is normally done either by the customer or with the customer's full knowledge and visibility. It's what the customer needs to see working before they will accept the system. Now, it's usually the minimum demonstration required by the client to show the system is fit for purpose. Nobody would do more than the minimum. Normally, it's a test of the functionality, and it's performed by the client. Or, the client will hire a testing company on their behalf, but it's a representative of the client. What to test? Usually they test the most critical functions and the most revealing tests. Exploratory testing is something I'll have to say something about. Programmers test to prove that what they've done works. This is quite normal. It's a very unusual person who can think of how something is intended to work, but also think of ways that can not work. That's a very unusual person. Most of the time, we tend to check that something actually works as we intended it to work. The tester, on the other hand, wants to know, can I break it? So there's a difference in the mentality between them. It really is not a good idea for somebody to test their own work. They just tend to miss some of the more subtle or evil bugs. So we have a tester. An exploratory tester does not trust the requirements or the specifications. That is because they know from long experience that the requirements change dynamically and are not always recorded back into the official requirements. Similarly, the specifications. What gets implemented is not what was specified to be implemented. It's whatever happens to be implemented on the day. So a good exploratory tester is hired to go and find out what the system actually is and what the system actually does and what it doesn't do and what it is not. Exploratory testing, as I've said before, is not for beginners. So in summary, we've had a look at unit testing, integration testing, system testing, regression testing, acceptance testing, and exploratory testing. And we've also had a look briefly at the economics of testing.